Testing, testing. Testing. Okay. I think the volume is good. Hi. Hello. Good morning. Or evening, wherever you are. Or afternoon. How are you guys doing today? I'm doing something a little bit more different and ambitious today. I found this site. Can you guys see this? I found this site where they listed out common interview questions at TikTok. I have no idea how accurate this is, by the way. This is from 2002 from Nodeflare. So I was like, oh, okay, maybe it would be fun to try some TikTok questions. TikTok questions are kind of notorious for being difficult. So this is going to be super fun for me. Okay, let's start. LRU cache. LRU cache. Design a data structure that follows the constraints of a least recently used LRU cache. Implement the LRU cache class. LRU cache in capacity. Initialize the LRU cache with a positive size capacity. Int get key. Return the value of the key if the key exists. Okay, so it's like a hash map. Otherwise, return -1. Void put. Update the value of the key if the key exists. Wait, what? Update the value of the key if the key exists. Otherwise, add the key value pair to the cache. Oh, I see. If the number of keys exceed the capacity from this operation, evict the least recently used key. The functions get and put must each run an O of 1 average time complexity. Excuse me. Dragon says this is a good question. Hey Dragon, by the way. Alright. You guys want to hear a funny story? I actually got this question in a real coding interview. And I didn't know how to do it. I think I got to the point where I recognized that I needed to store a linked hash map of some sort, but then I suck at link pointers, so the interviewer basically watched me struggle for 30 minutes. Linked list pointer errors like null pointer, stuff like that. So this is a good exercise, all right? Okay, so obviously it behaves kind of like a hash map, right? You can get a key and it returns a value. Okay, update the value of key if the key exists. Otherwise, add the key value pair to the cache. The number of keys exceed the capacity from this operation. Evict the least recently used key. Okay, so we only evict if we're doing a put operation, huh? It's impossible to evict from a get operation. Okay, we'll need some sort of hash map. The key will be, what's the key? An int? They gave us an int. And we will need our custom node object. because I need to point to the next one or their neighbors. So the node class will have, what will it have? The key value. I'm not sure if it will need a key value, but better more information than none, you know? Int value. It needs a link to its previous and next. So node, previous, next. Okay, what's going to happen when we initialize the cache though? Initialize the LRU cache with positive size capacity. Okay. I feel like all we need to do is store a capacity variable, no? And then, because we don't need it in the constructor, if we run put, then we need to track it somehow, the max capacity. Var in class. Okay, what do you do for get? Get key. Return the value of the key if the key exists. Otherwise, return -1. Okay, so just hash map. Let's call our hash map cache. So basically just cache dot get or default the key, else -1. Okay, what about put? Put key value pair. Update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Okay. Update the value of the key if the key exists. Okay. This is going to be difficult because complicated linked list node stuff. Okay, we should set some rules on our nodes. So the nodes are going to be connected like this, right? Like a node, double pointer is a node. Let's say that the left side is recent, right side is least recent. Update the value of the key. Evict the least recently used key. Okay, so most recent nodes should go in the front, least recent should go to the back. So we need some way to track the first and last nodes. Okay, I remember the interview where I tried to do this. This is what kept messing me up. Because I kept trying, because what if the start node is deleted, right? Or the end node is deleted? It adds so much complexity. So I think I will add some like bogus nodes in the cache, like bogus nodes that are never deleted. The start and end. And then they point to the start and end of the cache. We should probably have some helper functions too, right? To make deleting and adding nodes easier. Let's do a... Let's make some helper functions like remove node. Key. How the heck do we remove a node? Okay, so it's previous dot next is equal to let's say this is previous, this is next, previous dot next is equal to next, next dot previous. Oh, this is really confusing. Should I give them different names? I already named the pointers to previous and next. Maybe I will name them as just A or B. So A dot next is now equal to B. Okay, I gotta be careful on this. I am notoriously not good at this. B dot previous is equal to A. Does A's previous change? No. Does B's next change? No. Me does change though, right? Me dot next is equal to null. Me dot previous is equal to null. I think that's what I need to do. And then I can return me. Since I might have to add it in the end. Okay, what about add node? Where do we need to add our nodes? Usually to the beginning, right? As the most recent node? Is there a place where we need to add our nodes? Anywhere else we need to add our nodes? Do we ever add it to the end? To set it as the least recent? I don't think so. Okay. Add node to start. Maybe that's all we need. Okay. We also have our start and end nodes here, so start.next. Okay, let's look at this example, yeah? This is the start node. And this is kind of like the bogus start node. And this is the, what do I call this? New second node. Sure. Start.next is equal to me, the start.previous change? No. What about new second? New second.previous is equal to moi. Does new second.next change? No. Me.previous is equal to start, the bogus start node. Me.next is equal to new second. Okay. Man, imagine if I tried doing this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4. Like 8 operations without helper functions. I would be so confused. Okay, so when I get key, when I get a key, I need to set it as the most recent node as well. So in addition to this, I need to remove node and then add back to start. For putting a node, oh, I need to check if it already exists, huh? If exist, remove and add to the first. Also, I need to update it. And else, I need to add it to the front. Just add first. If the number of keys exceed the capacity, evict the least recently used key. Evict if necessary. Man, thank you guys for tolerating my glorious handwriting. I feel like this is a plan, no? Let me read the problem requirements again. Initialize the LRU cache with positive size capacity. Okay, we have a capacity. Get key, return the value of the key if the key exists, otherwise return -1. Yes, cache getter default, and then we also remove the node and add it back to the front. Put key. So if it exists, we remove it and then update it and add it back to the first. Otherwise, add the key value pair to the cache if the number of keys. Yes, okay. Else, add to the first. If the number of keys exceed the capacity from this operation, evict the least recently used key. Yes, evict if necessary. Okay, I think this works. Does get work in all one time? Get is cache, get or default. Remove a node and add back. Yeah, that's the same for everything. Put. If it exists, remove add. Else, add, evict. Yeah, it's O of 1. It's the same for everything. Okay, let's start coding. We have a int capacity. In the constructor, this dot capacity is equal to capacity. Okay, getting a key. Before that, actually, let's do our hash map. Hash map, integer, looks like the value is also an integer. Thank goodness they never do like, you know those any class stuff? Like you can put any object into the parameter. That will be annoying as heck, but LeetCode usually just says integers, which is nice. Cache. In the constructor, cache is equal to new hash map empty hash map. Man, it's gonna be really hard to test this in between implementations, because I can't test put without get very easily, unless I print out what the cache is maybe. Should I just try to implement put first and then try to sanity check it by printing out stuff? Maybe that's what I'm gonna do. Okay, put relies on two helper functions, remove node and add node to start. Private. Oh, I'm missing a whole node class. Should this be an embedded class? I feel like nothing else is going to use it, so probably. Class node key value node previous node next. And then the helper functions. Remove node. Maybe let's return the node that's removed. Remove node. Let's add a key in here. Okay, let's get some base cases out of the way. If cache dot contains key, if it does not contain the key, return null. Hopefully that never happens. Okay. A is equal to previous node. B is equal to next node. Node A is equal to I need to get the node first. Node me is equal to cache dot get key. A is equal to me dot previous. Node B is equal to me dot next. Okay, and then we just do what I wrote here. A dot next is equal to B. B dot previous is equal to A. Me dot next is equal to null. Me dot previous is equal to null. And then return me. Man, I can already imagine this is going to be so hard to debug if anything goes wrong. Private node, add node to start. Maybe we'll take in the node this time. Me. Base case, if me is equal to null, then return, I guess. Okay, and then you do this whole shtick, add node to start. Which reminds me, I forgot the bogus start and node. Start and end nodes. Node, bogus start, node, bogus end. When we initialize this, maybe bogus start is equal to new node. Oh my goodness, this is already so complicated. I need to add a constructor to node. Public node. And key into value. This dot key is equal to key. This dot value is equal to value. -1, -1. Bogus end is equal to new node with some bogus values. -1, -1. Bogus start dot next is equal to bogus end. Bogus end dot previous is equal to bogus start. I think that's what I need to do, since there's nothing in the cache initially. Oh, this is already so complicated. Add node to start. Okay, what did we say we needed to know for this? We needed the bogus start, and then the original start node, aka the new second. Okay, we already have a reference to bogus start. We need a reference to this new second. New second is equal to bogus start dot next. Can I do that? Oh man, what if new second is the bogus end node? Would that still work? Let's see, me start.next would be me.previous. I mean, the bogus end would point to me, so I would be the start and the end. I guess that makes sense. And the me.next is equal to end. I guess that makes sense. Okay. Bogus start is equal to bogus start.next is equal to me new second dot previous is equal to me dot previous is equal to bogus start. Me dot next is equal to new second. Holy, I'm so paranoid now. Let me double check this. Bogus start dot next is equal to me new second dot previous is equal to me dot previous equals bogus start, me dot next is equal to new second. Okay, sounds good to me. Man, this is going to be so difficult to debug with all these pointers. Okay, we got our helper functions. Let's minimize these now, because I don't want to see how messy this is. Okay, put operation. What did we say our put operation is? Okay. If cache dot contains key, then you remove the node from its current location, node, n is equal to cache dot get key. We updated, so n dot value is equal to value, and then we put it back to the first. Add node to start, and I think that works. Else, you automatically add it to the first value. So node, new node is equal to new node, key comma value, and then you automatically add it to the first. Add node to start, new node, and then you do a capacity check too. Capacity check. How do we do this? Current capacity is equal to cache dot keyset. I think you can do that, right? Keyset. Is that how you get a list of all the keys in a hash set? Java hash map keyset. Create a set out of the key elements contained in the hash map. Okay, I think that's how you do it. Key set. Excuse me, I just drank some water. If current capacity is greater than capacity, this is very vaguely named. I want to give it a better name. Max capacity. So I need to update it in the cache too, or in the constructor. This max capacity is equal to capacity. So if my current capacity is greater than my max capacity, time to start deleting some nodes. What's the end node? node, the real end is equal to bogus end. Is that what I called it? Yeah, bogus end dot previous. What did I call my helper function? Remove node. Remove node. The real end ends here. Okay, and for testing purposes right now, I just want to print out my hash map, I guess. Does a hash map print nicely if you just put in system.out.println Java hash map to string? Oh, I guess it does print nicely. Okay. System.out.println cache. Okay, sanity check time, which means I need to log into LeetCode. Give me 1 second. I always forget to log into LeetCode, but it's fine, it doesn't take that long. I typed in my password. Okay, we back. Bam. Oh, okay, sanity check time. The test case will do 2 puts, so it will do 1, 1, 2, 2, and then we should fail on the get, because we have no get yet. We'll just return -1 for now. And then hopefully our cache will print out a 1, 1 and 2, 2 in the cache. Let's go. Integer cannot be converted to LRU cache.node. Am I? Oh, there should be a node. Oh. Do I have any other instances? Cannot find symbol on line 60. Contains key. Cannot find symbol. Add node to start. Is that not what I named it? Oh. 2 is capitalized. Run. Set integer cannot be converted to dot size. Cannot find symbol, read end. It should be real end. L and D are not even on the same side of the keyboard. Remove node. Node cannot be converted to int. Oh. Dot key. Seems kind of roundabout, but I guess I'll have to pass in a key. Sure. Okay. It ran. Okay. This is not good at all. Our standard outs are completely empty. Fantastic. Why? Oh, we never touch the cache, huh? Do we? We just keep manipulating our nodes, huh? Yeah. Okay, we need to actually add it to the hash map. Cache dot put key with new node. Does our update function work with this too? Cache.get. We're manipulating the node that the cache key points to, right? So it should be fine. No need to put in the cache again. I feel like that should be good. What? They lied to me. It doesn't print nicely. Dang it. How are they printing it? Map to string. Oh, to string? Does putting it in println not already put into a string? Oh, it does actually. But we need our nodes, our node class to be prettier when toStringed. Public toString return what? The value? Return value plus string. Okay, let's run this. Okay, I think put is working. We have 1, 1, 1, and then the 2's. If we try putting 3, we get 1, 1, 2, 2, 3, 3. Wait, that's not right. That's not right. We need to evict stuff. When we remove from the capacity, I see. We need to remove from the cache too. So cache dot remove key. Wait, no, not the key. Real n dot key. Okay, one more time. Okay, 1, 1, 2, 2. Then it becomes 2, 2, 3, 3. Remove the 1, and then 3, 3, 4, 4. Okay, I think put works. Put works now. Very nice. Now for the getting part. Let's get all right, we need to remove the node and add it back to the front if it already exists. If cache dot contains key, what do we do? Return it? Yeah. Okay, we need to remove the node to the front too. So node, me is equal to cache.get key update to most recent. So what do we do? The helper functions. Didn't I do this before? I don't want to think too hard on this again. Oh wait, I didn't even need to think that hard. All I had to do was add the node to start. Wait, didn't I have to remove the node? Or else the pointers will get really messy too. So to be safe, I'll do a remove node too. Remove node key. Remove node key. Node me is equal to remove node. Add node to start, and then return me. Does remove node find it in one time? Yeah, it does. Okay. Return me. Else, if you don't contain the key, now contains key. What do you do? Return -1. Let's run this. Line 63. Add node to start. For get. Reggie says, hi, what's up? Or yo, what's up? Hey, how's it going? I'm trying TikTok interview questions today. They're supposed to be really difficult, and I can feel it. I can feel it already. But yeah, hey Reggie, how's your day going? Hope you're doing good. Int get key, update to most recent. Oh, this should be me. I'm doing the LRU cache problem, by the way. I'm basically doing a hash map with a custom node class as the value. And then I'm making them point to each other to keep track of order. Node cannot be converted to int 65. Oh, return me.value. Reggie says sounds complicated. Oh, shizzle. Yeah, it's complicated too. Yeah, I had to make so many helper stuff. Like, there's a freaking node class, and then 2 helper functions, remove node, and add node to start. Yeah, I told Dragon this, but I actually got this question in a coding interview before, and I did not know how to do it. Because look at how many sort of linked list pointers or node pointer operations I have to do. I was really struggling with this in the interview. The interviewer basically spent like 30 minutes watching me try to debug node pointer exceptions, like node doesn't exist, null pointers. Yeah, but I have learned. I've learned to make a bogus start /end node to remove a lot of dumb edge cases, and also make helper functions for removing and adding nodes. So hopefully it should be less of a headache. Yeah, if this doesn't work, no. Yeah, if this doesn't work, it's gonna be really difficult to debug. Is it because I'm printing out my cache? Let's go! My life is complete. I finally beat the stupid LRU cache. I think I deserve a break after that. Yeah, this problem gives me maybe a little trauma. Because I failed this in an interview before. I think I'm gonna take a little breather now. I'm not gonna go, but I'm just gonna take a break from coding. Dude, I literally wrote 91 lines of code for this. That's almost like a system design basic question. Reggie says, I'm good. Sounds complicated. But yeah, what have you guys been up to lately? I have been watching more One Piece. I am on... Reggie says, do you check out the optimized or best solution right after solving a problem? Depends. Sometimes I do. If I'm already too tired, I don't. Okay, this is in Ruby. This is in Java. Okay, they made a new node class like me. Track the key value previous. Oh, this is basically like me. Add node. Delete node. Get. Wait. This is my get function. If contains key, remove key. Delete node, add node. Put it to the front again. That's basically what I did. Reggie says, this guy have provided a lot of answers to solution. I feel like that's what I did. Okay. Rahul Larma 5297. Yeah, I feel like I've seen his name a lot on the solutions. Whoop. There's this other guy that... Wait, is Rahul the one that sometimes puts his YouTube channel link here? He sometimes has a video to go along with it. Oh, yeah, I've seen this before. Apparently there's this class in Java that implements this linked hash map. So all you need to do is extend the class in Java, call the superconstructor. That's the capacity, I believe. Don't know what this is. This is the evict condition, I believe. If the current size is greater than max cap, get is just super or default key -1. And then it handles the node update for you. I don't think they will allow you to use this in an interview though. I think they want to see if you can think it out from scratch. This is a Java solution. Why are there so many sections? I feel like everyone's doing the hash map with custom node class. Yeah. Is it gonna be faster if I submit again? Now it beats 50%. Alright. But yeah, I have been watching One Piece lately. I am on Enies Lobby. Not done with it yet, but nearing the end. Yeah, I think it's a solid arc so far. I am engaged, which is like a really big thing to say for early One Piece arcs. Early One Piece arcs are sometimes like very long and slow pace-wise, but this one has my attention. I still think Water 7 is really, really good though. Enies Lobby doesn't really beat it so far. Yeah, but I'm engaged, so it's still gonna probably get a high rating from me. I really like the Square Giraffe dude, one of the CP9 members. I feel like he's so... he's trying to act so cool, despite the sort of goofy handle cards he's been dealt with. Dangkyeku. He just turns into a box and it starts flapping. Pasta machine. But yeah, such a stupidly goofy character while trying to act cool at the same time. Yeah, and then Zoro is the very nice reactor to his goofiness. Oh yeah, and for the first time, you kind of feel like that Luffy isn't overwhelmingly like OP against the villains. Reggie says, I also read and watched One Piece. Oh, you have? What arc are you on, Reggie? Reggie says, but I haven't watched any anime and read manga about 2 months, I guess. Oh, sick. Yeah, which arc are you on? I think I was at the Wano arc. Oh, I don't think I've gone there yet. Is it getting good at the Wano arc? Yeah. Allegedly, the first 300 episodes or so of One Piece, anime-wise, is supposed to be kind of long and slow, but everyone says it's supposed to get good after episode 300 something. Oh wait, you're at the Wano arc. I'm looking at the arc list. That's really far. You're like really far away. Nice. You're like just one arc behind the latest anime arc. The battle between Luffy and Kaido. I don't know who Kaido is yet. But hey, are you enjoying it? Is it true that it's getting good? Okay, let's move on to the next TikTok question. Top K frequent sums. I also feel like I've done this in the past before, but don't remember the solution. Reggie says it's good if you don't force yourself to watch. Oh, just enjoy it as it is, huh? I feel like before Water 7, I was kind of forcing myself to watch. But especially for Arabasta, that was very long for me. The ending to Arabasta was really good though. It felt like a really grand and large scale ending to like a fairy tale. I really liked the ending, but yeah, the middle felt really long. It dragged out a lot. But I really did enjoy Water 7. Water 7 was, I don't know what it is, maybe it's the world. The world feels really comfy. But I was engaged all the way through, and I really enjoyed. Yeah, I have no idea why though. It just was a really interesting arc to me. Reggie says, I think I've solved this one, but it was a long time ago. Yeah, same. Long time ago for me could also have been like 2 weeks ago, because I have bad memory. Given an integer, okay, so top K frequent elements. Given an integer array nums and an integer K, return the K most frequent elements. You may return the answer in any order. Dragon says, oh, you solved that LRU? Yeah, I did. I solved it. See, well, it did say 50%, but 39% now. I will take it. Yeah, it is a big win for me. Dragon says linked list? Kinda. I made my own custom node class and made a hash map with keys, integer keys that point to the nodes. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay, I somehow need to keep track of the counts of every single character or element. That sounds like a hash map, no? Hash map. Okay, so in this example, they give us this, k equals 2. So we return the top two most frequent elements, which is 1 and then 2. 1 is 1. Okay, for counting stuff and keeping track of counts of multiple things, it's usually a hash map, right? I'm writing so big now. Key will equal to the element value is equal to count. I think that's pretty straightforward. I will iterate through every single element and increment its count in the hash map. And it should be O1 axis, because hash map. Okay, I somehow need to iterate through the hash map again, and then get the k top counts. That sounds like sorting, no? How do I sort the... Oh, this is going to be kind of a hassle. How do I get the hash map entry set? Oh, I've searched this before. Entry set. It returns a set having same elements as the hash map. So it returns a set of the entries in the hash map. Okay, so it returns a set. Entry set. It returns a set of map.entry. I guess that's like a embedded class in the map abstract class. So if it's a set, that means we can try to sort it somehow. Java sort set. Temporarily create a list and sort that. Okay, so we can put our set into a list and then collections.sort. We want to sort by the count though. How do we do that? Java collections.sort by okay, we can implement a comparator class apparently. Oh, this sounds like such a hassle. Isn't there a one-liner way you can do this? Collections Java collections that sort by comparator one line. Oh, here. Is there a way to input like a lambda? Oh, here. Comparator comparing. Okay, so we would input the comparator to here, I guess. Comparator.comparing, what does that return? Comparator.comparing. Comparing. It returns a comparator. Okay. Collections.sort comparator. comparator. Okay, so I guess you can insert a comparator here. Man, so many tabs open. Okay, so... Ooh, so many... Okay, so we can first convert this to a list with entry set. And then we can convert it to a list with list constructor. And then we can sort the list with collections.sort. With the list and comparator. We can do like comparator dot comparing comparator dot comparing comparator dot comparing I guess comparing and then in comparing we would put a entry set and we would return entry set dot what? Get value. And we would take the first does collections.sort sort by least to greatest first or what? Collections.sort order in ascending order. Okay, so we would get last k elements. Or not get, just return last k elements. Okay, I think that sounds like a plan. It's kind of roundabout, but I think it will work. Let's go. First, we have a new hash map, integer, comma, integer, counts for every int num in nums. Counts dot put. We should get its original value if it already exists in counts. And existing value is equal to counts dot get or default num comma 0. we'll just return 0 if it doesn't already exist. Put num plus existing value plus 1. Okay, we need to be careful. We're converting it into a bunch of stuff. Convert to set. And then to list. I don't want to make a whole new variable for it. List. Actually, I want to be careful here. What set are we returning here? Set. Okay, we are returning set map entry. Integer, comma, integer. Ooh, this is getting messy. Map. To set is equal to count dot entry set. Convert to list. List. To list is equal to new. Is array or linked list faster for sorting? Is array list or linked list faster for sorting? Array list is faster. Okay. New array list. To set. And then we will sort it. Collections.sort to list with comparator.comparing entry set. Entry set dot. Ooh, these lambdas they always confuse me. Get value. And then we will get the last k elements. You know what? I'll do a sanity check now. I'll just print out to list. System.out.println to list. Hopefully it prints out something pretty. What's the test case? 1, 1, 2, 2, 3. Okay. Oh, I never initialize counts. It's equal to new hash map Okay, this is our Did we actually sort it successfully? One appears 3 times, 2 appears 2 times, 3 appears 1 time. Dang, I think we did it. All we have to do is return the last k. Okay. We return a int array. Okay. Result is equal to new int k. So we start from the last index of toList and then move back until we have k. For int I is equal to toList dot size minus 1, I is greater than wait, how do I want to do this? Int toList I, let's make this more clear, is equal to toList dot size minus 1 How do I do a for loop with multiple variables? Java for loop, multiple vars. Let me hydrate. Oh, it's just a comma between the different elements. And okay. Man, I've always had trouble with for loops with multiple elements. Should I just iterate through result instead? I is equal to int I is equal to 0 while I is less than result.length I++, and then outside of here we'll do toList I is equal to toList dot size minus 1 Okay. Result I is equal to toList I minus minus. Okay, another sanity check. Let's print out result. I don't think lists print out very prettily. Arrays dot toString. Man, why am I doing this? I could have just returned it. Okay, I think I got the right answer. Return result. Oh. Okay, case 1 passes, case 2 does not. Yes, we should have 1, not 0. Let's print out our list. To list. Okay, our list is right. Is it the way we're filling up our result list? To list size I-1. I think that's right. Oh. It should be the... Why are we filling in the index over here? It should be toList dot get toList I dot this is a list of map.entry, right? So how do I even get the value from here? Oh, get value. Wait, how did the first case even pass? Well, beats me. Is it because it's a function? Oh, get key. Hey, it works. Let's try submitting. Oh no. Am I still not getting the key? Reified says, hi chat. Hi Reified. How are you doing today? Get value. Get key. Reggie says, sorry I was AFK. Why we need to convert to list? Oh, here? Because I wanted to use collections.sort. I couldn't figure out how to sort a set. Yeah, what I read online on Stack Overflow was you can convert it to a list and then sort it with collections.sort. Reified says, how are you? I'm doing good. Yeah, I'm doing good. This morning I woke up, I had a blueberry bagel. It was pretty nice. I've been watching a lot of One Piece lately. I'm on Enies Lobby. It's pretty engaging so far. even though I haven't gone to the time skip yet. Well, runtime is poop. It does work though. Also, I am printing out some extraneous stuff. Maybe that adds to the runtime. Submit again. Better? Okay, let's look at some solutions. Apparently it can be much better. I see this guy a lot too, with the Relvo person. First, we count frequency of each number. Yes. Next, we use heap. So we use tuple and heap. Okay, he uses a map counter. Yes, that's what I did. He uses a priority queue. Which takes a lambda. Reify says, do you know about heap as a data structure? In Java, it is priority queue. Oh, yeah, I haven't really heard about heaps. I have heard about priority queues in Java, but I've never really used it before. Okay, so for map, in entry, in counter.entry set, heap.offer. What does that mean? Heap.offer. Java priority queue offer. Reified says, I figured out with heaps not so long ago. Oh. Offer method is used to insert a particular element into the priority queue. It acts similar to the add method of priority queue. What? The element to be inserted into the queue. Oh, okay, sure. What's the difference between offer? Yeah, offer versus add. Oh, okay. Offer returns false if it can't add the element. Okay, I guess it's the same. Result is equal to... Oh, hi Simon. Hello. How you doing? Welcome to the stream. I am doing top K frequent elements. And I'm currently looking at priority queues now. Okay, so my way is currently, I'm counting everything in the hash map like they are, but I'm converting it to a set, and then converting it to a list, and then sorting it, and then getting the last 5 elements. Or last k elements. So they're just popping. Wait, what is this? Objects that require non-null. Heap.pull.getKey. Does it have to be this complicated? Objects that require non-null. Let me look up what this does. Does it just throw an exception? Okay, so it throws, yeah, it stores null pointer. Heap.pull. Okay, and I assume that a priority queue automatically stores ascending order, huh? So all we have to do is pull. Sure. Okay. Pull gets minimal element and removes it. It gets the minimum element, but we're trying to get ascending order, right? Does it do it backwards if it's like b.getValue, a.getValue? Peek just gets. I see. Pull gets minimal element and remove it, peek just gets. Okay. I think I want to try my hand at priority queue too. So I don't have to convert to a set or a list. And probably remove all this. In this case, it is max element. Okay. Okay, let's try a priority queue. I mean, I can literally just copy what they have here. In special cases, PQ is more efficient than sorting. Is it? Is priority queue faster than sorting Java? Dang, there's priority queues which work one time if integer data. That's crazy. Okay, so I need to replace counts. So no need for this. No need for this. Result I is equal to the heap. Heap.pull, and it removes it, right? So we should be good. Dot get key. There's no need for this anymore. Man, I'm really bad with comparators in Java. I would not know that I need to do this. Integer.compare. What does this do? Integer.compare Java. Okay, given xy, if x is less than y, returns a value less than 0, and if x greater than y, returns a value greater than 0. Okay. I assume usually you put A first and then B, right? But this time they put B first and A. So it goes in reverse order, right? Okay, let's try this. Heap. I misspelled heap. Man, maybe I should study priority queues more. 55%. That's actually about the same speed. Comparator.comparing. Simon says, priority queue is very powerful, needed for many algorithms. Man, so many people know each other in chat. Comparator in one line, Java. Okay, I'm just looking at comparator.comparing. Integer.compare. I see. This is just like lambda, huh? So if you're comparing A or B, return integer.compare. Priority queue initialization. Dragon says, just like how MinHeap is used in today daily of industry. Custom comparator. Lots of people are using integer.compare. Okay. I guess that's something to keep in mind with in the future. What does integer.compare return? Integer.compare. Simon says, whenever I'm writing custom comparators, instead of A and B, I like to use LHS and write RHS. It helps me visualize the order, but I guess A and B also work if you think about the way the alphabet is. I see. What does LHS stand for? Left, hand side? Oh, right hand side. Okay. I see. So basically just return 0 if they're the same, and -1, or, I mean, a negative number or a positive number, depending on, oops, sorry, I bonked the mic, if it's bigger or less than. Okay, makes sense then. Should I do one more problem? My brain is already really close to being fried right now. Next one is a really easy problem, allegedly, and I feel like I've done this before. Twosome? I may have done this on stream before. Comparator return -1, 0, or 1. In Java, possibly any negative number instead of -1 or any positive instead of 1. I see. When I learned JavaScript priority queue library, it works like the sort AB. Okay. Very nice. In JavaScript, 0 equals no sort. 1 is left-hand side swap with right-hand side. -1, the opposite. I see. Thanks for the insight. Should we try this easy question? I swear I've done this before. Given an array of integers nums and integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. Okay, you can return the answer in any order. Okay, they make our lives a lot easier by saying exactly one solution, may not use the same element twice. Okay, sounds good. Don't we just iterate through everything? Keep track of everything in a hash set? If I see my complement, i.e. the thing that would add me to the target, I just return that and its index and my index. Okay. Hash map, integer, mem is equal to new hash map. For I is equal to 0, I is less than nums dot length, I plus plus. Okay, what do we do? Int current num is equal to nums I, int my complement, basically the thing that would add me to the target, is equal to target minus current num. If mem dot contains current num return arrays dot to wait, how do you instantiate a array list literal in Java? Java array list literal. Oh, not array list. Array literal. Oh, just this? Sounds good. Return mem dot get, because we're returning the index, right? Return the indices, okay. Oh, this should be the complement, comma, I. Else, if it does not contain the complement, add me to memory. Mem dot put the current number, comma, me, the current index. Hopefully we never get to the end here. -1, comma, -1. Is this actually how you make a array literal? Shouldn't it be more complicated? Yeah. Do I have to put new int here? Contains key, maybe? Sick, it worked. Let's go. It beated 98%. I probably did this problem before, right? Let's go, says Dragon. The first question everyone first solved. Yeah. Alright, we did LRU cache, top K frequent, to sum. It is 11 o'clock a.m. in my time. I think I will call it a day. Thanks everyone for popping in. Thank you, Dragon. Thanks, Rayified. Thanks, Simon. Appreciate you guys coming. I will see you guys tomorrow then. Bye, Dragon. See you tomorrow. Bye, Simon. Goodbye.